Hello everyone and welcome to a new video wherein I've got a problem from polynomials and a bit of binomial coefficients properties. So it's a very beautiful question with a very good solution. Make sure you give it a try before looking at my solution. Without further ado, let's begin. So the question says that let n greater than m greater than equal to 1 be integers, and we have a polynomial p of x defined as summation k equals m to n choose k times k choose m times x to the power k. This is the polynomial and we have to comment about the roots as given in the options. So for that we need to figure out the roots, and for that we have to simplify this polynomial. The problem that is being caused is not this x to the power k, it's actually this whole term. So let's try to simplify the uh, term, which is n choose k times k choose m. And what I'm saying is that this can also be written as n choose m into n minus m choose k minus m. But this is the critical step. Now, why have I written like this? Let's think about it in a combinatorial way. So if we look at the LHS, which is this part, so what does this mean? Let's think it in this way that we pick, like imagine you have a group of n people and you need to form a committee of k people, and from that committee you need to appoint m people to a subcommittee. So now the LHS is pretty simple. You first pick out k people from the n people, and out of those k people you select further m people and you multiply it. Now what the RHS means is that we pick the M subcommittee members directly from the whole group of N people and then choose the remaining K minus M general committee members from the remaining N minus M available people. So this is true in both cases. It makes sense. And if it's not still convincing, you can even check it algebraically. You will get the same result if you expand the left hand side and right hand side. Right, so this is the critical step that we're going to be using. We're going to be substituting this value into the summation instead of this term. So what we get here is that p of x becomes summation k runs from m to n. Now we write it as n choose m times n minus m choose k minus m times k x to the power k. Now you see that n choose m becomes a constant, so we can pull it out of the summation, and this is what we get. We are still not done with the problem. Now the problem is this whole summation, and this is still easier to solve than the previous one. We have simplified it till a great extent. Now what I see here is that anything, if there's a binomial coefficient like n choose 0 and then you see x to the power something, uh, this should click that you can see something like 1 plus x to the power n expansion here. So let's try to create that. Now how can you create it? Here you have x, here you have k minus m. So it would be lovely if I had k minus m over here as well. And we can actually do that. How? Let's see it. N choose m times k runs from m to n. N minus m choose k minus m into x to the power k minus m. Now that we have written x to the power minus m, we'll also have to multiply to balance it out. So we can write x to the power m over here. And this is the same thing as the previous one. Now this is nothing but 1 plus x to the power uh, n minus m some expansion. Just to make it simpler, what I can do is let's assume k minus m as j, and now if we see the summation, this and this, the limits, if I'll just write it over here. The polynomial now becomes n choose m x to the power m times summation. Now k starts from m, so j starts from 0 and goes all the way up to n minus m. And now we can write this as n minus m choose j times x to the power j. And this is something we are all familiar with. This is nothing but 1 plus x to the power n minus m expansion. So this is what we finally get, 1 plus x to the power n minus m. And this is p of x that we get. And now you can easily find the roots of it. We see that one root is 0 and the other is minus 1. So we are being asked the multiplicity of 0 and minus 1. So clearly the power of x here is m. So multiplicity of 0 will become m, and similarly multiplicity of minus 1 will become n minus m, because the power of 1 plus x over here is n minus m. So we get the right answer as the A option. A very simple question, a very beautiful solution. The critical step was this step where we wrote n choose k into k choose m as n choose m into n minus m choose k minus m. And the rest was simple manipulations and getting it in the form, converting it into a form that we know how to solve, which is this form, the 1 plus x into n minus m form, and finally get the answer which was asked in the options. So that was it for this video. Hope you enjoyed it and thank you for watching it.